Questions 11 through 20 of the 2001 Grade 11 Fermat Math Contest. The fourth root of 2001, 2001, 2001, 2001, that is of this form, is closest to. So let's say we have this big long number, which is essentially 2001 written 4 times, not multiplied by each other. It's just one integer. These are all digits. And we want to take the fourth root like that. And this is going to be, say, some x. Well, if we take everything to the fourth power, this will disappear, and you'll just get left with 2001 written 4 times like that. But this becomes x to the fourth, correct? Now x to the fourth is x squared times x squared. So you have to basically have 2 numbers that when you multiply them together will equal this big long number. So to get each of them, you would have to write it like this. I hope this is a little bit more intuitive. X squared, and then whatever you get, you square it again. So that means you would have to basically take the square root of this twice. So to get the first x squared, I'll just write it out so it's not confusing for you, like this. To get the first x squared, you'd have to just take the square root of that, correct? And then once you get that, you can now take the square root of that again to get x. So I know it gets kind of cumbersome to write it out, but you can do this on your calculator. Most calculators nowadays can go, if you turn it sideways on your phone, you can write out that many digits, 16 digits. So write it out, then take the square root once, and then take the square root again, and you will get a number that is a 6688.4 approximately. And that number is closest to choice B for number 11. How many integer values of x satisfy x minus 1 over 3 is less than 5 over 7, which is less than x plus 4 over 5? So write this out like that. And first I will just look at the first 2 right here. So if you just look at those 2, look at that over here. We got x minus 1 over 3 is less than 5 over 7. So if we cross multiply, we get 7x minus 7 is less than 15. 7x is less than 22. X is less than 22 over 7. And that is approximately 3.1. So x is not equal to 3.14, but it is less than that. All right, so that's our first condition. Now we'll look at these 2 guys. We'll look at them over here. So we have 5 over 7 is less than x plus 4 over 5. So cross multiply, and you will get 25 is less than 7x plus 28. And therefore 7x is less than minus 3. So x is less than minus 3 over 7. And x, that is approximately what? Minus 4? 4.2? Around there. So those are our 2 conditions. So x is between, it's less than 3.1, and it's greater than minus 0.42. So how many integers? That's what they're asking, right? How many integer values? How many integers are between minus 0.4 and 3.1? Well, 0, 1, 2, and 3. So we have 4 integers that are in between those boundaries. So the answer would be 4. So number 12, the answer is E. A, B, C, D, E, F, G, H is a cube having side length 2. P is the midpoint of EF, as shown. The area of APB is. So APB is this triangle right here. They want you to figure out that triangle's area. Okay? So we first need to figure out how much do we know. Well, we know the side length is 2. So in triangle ABP, this one right there, we at least right off the bat have one side, which is AB. Now we need to systematically work to get the other two sides so we can figure out the area. So I'm first going to concentrate on PB, that side length. And that looks like if I draw a line from P to G, I can then use Pythagoras, because that will be a right triangle right there. PGB will be a right triangle. So first I need to find PG. Well, if you notice, this is a right triangle right there. PGF is a right triangle. It doesn't look like that because it's on a slant, but it is, right? Because the base of that cube is a square, and those corners are at right angles. Okay? So what do we know about that? We know this is 2, and these lines here are important because they basically denote that those two sides, those two lengths are equal. So if the full side is 2, those are 1 and 1, like that. So in this triangle right here, we can use Pythagoras to figure out PG, all right? So that's step number 1. PG squared will be 1 squared plus 2 squared. So this is 1 plus 4, which is 5, and therefore PG is equal to root 5. All right, so I'll squeeze that in there, root 5. Now we know that PG is root 5. BG, all the way there from top to bottom, is 2, because that's just the side length of the cube. Now we can use Pythagoras to figure out B to P, all right, or PB. So PB squared is root 5 squared plus 2 squared, which is 5 plus 4, which is 9, and therefore PB is equal to 3. So PB is 3, so put that in there. Great. Now we have 2 of the side lengths. Now we need to concentrate on AP. And AP will be calculated in a very similar way. Very similar to what we just did over with PB. All right, so now let's look at AP. If I draw a line from P to H, it's going to be a little bit harder to see because this is very narrow, but I hope you can see that. Maybe I'll make it a little bit bolder. So P to H, like that. So I hope you can see that. And then A to H is right there, and that is also a right triangle. I know it's difficult to see, but if you are convinced that the base of this cube is a square, then you hopefully will understand that the corners are all going to be right angles. So this triangle AHP we can use to figure out AP. But before we do that, we need to figure out HP. But HP we can find with that triangle, HEP. Remember exactly the way we did with the other value. EP is 1, HE is 2, and therefore we can find HP. So HP squared is going to be 2 squared plus 1 squared, which is 4 plus 1. So therefore HP is equal to the square root of 5. And stick that in there like that. And then now we can figure out AP. AP squared is equal to AH squared, which is 2, right? Because that's just the side length, plus root 5 squared. So this becomes 4 plus 5, which is 9, and therefore AP is equal to 3. There we go. Now we have all three sides. We have 2 for AB, 3 for AP, and 3 for PB. So now, to avoid making this messy, I'm going to draw it over here. I'm going to draw APB. So there you go. This is our triangle that we want to figure out the area of A, B, P. And we know that this is 2, this is 3, and this is 3. Now immediately you can recognize that that is a isosceles triangle, correct? And if you draw a perpendicular from P to the base like that, you will cut that in half, AB, but more importantly, you will create a right angle right there. And if this green line represents the height, and this is 1 and 1, we can now figure out h, which will be the height of that triangle. So h squared plus 1 squared is equal to 3 squared. So h squared is equal to 9 minus 1. So h is equal to root 8. And now finally we have enough to figure out the area of APB, which is what they want us to figure out. Yeah, the area of APB triangle. So it's 1/2 base times height. The base is from here to here, which is 2. The height is h, which we calculated as root 8. And therefore this becomes just root 8. So therefore the answer to number 13 is A. The last digit, that is the units digit of 2002 to 2002. Okay, these are very popular questions on math exams, math contests, I should say. Units digit questions. And the key to these questions is not to figure out what 2002 to the 2002 is. That would take forever. But the key is to look at the lower values, 2002 to the power of 1, 2002 to the power of 2, like that, and look for a pattern. And almost always you will find a pattern either quickly or it might take a little bit of time, as long as you don't make a mistake and mess up the values. So let's do this and let's see what we get. So I will do 10. Well, let's do 8. Okay, so you don't really need the numbers, you just need the units digit. And you can easily do this on your calculator, or you can even do it manually if you prefer. So 2002 is just 2002, right? So its units digit, the last digit, is 2. This guy right here. 2002 squared, if you do that, it will be some number, and its last digit will be a 4. Okay? You can kind of even figure that out. 2 times 2 is 4. And then if the last digit is 4, and you multiply that by 2, you will get a units digit of 8. And again, you can just take this 2002 times 2002 times 2002 in a calculator and look at the last digit. It will be an 8. And very similarly, you do the same thing with that one, and you'll find that it will be a 6. And then the units digit of 2002 to the 5 is 2. The units digit of 2002 to the 6 is 4. The units digit of 2002 to the 7 is 8. And the last units digit is 6. So I hope you can see there is a pattern here, 2468, 2468. All right? So we have to now figure out what is it for 2002 to the 2002. Well, notice something here. Every time that you have a exponent that's a power of multiple of 4, the units digit will be 6, right? So 4, 8, 12, 16, anything that's a multiple of 4. Well, the first thing I want to see is 2002 a multiple of 4? Is it divisible by 4? If it is, that'd be great. But it's not, right? Because it'll be like 500.5, I think. So that's not an integer. But 2,000 is a multiple of 4. It's 500. So that means that 2002 to the exponent 2000, which is a multiple of 4, will have a units digit of 6, according to our pattern. So therefore, 2002 to the exponent 2001 will have the next number as its units digit. And if you continue following that pattern, 2002 to the exponent 2002 will have a units digit of 4. So number 14, the answer is A. A circle is tangent to the y-axis at 0, 2, and the larger of its x-intercepts is 8. The radius of the circle is. So let's do some labeling here. The first thing is I'm going to put the center of the circle right there, and we'll draw a line from the center to the tangent, which is right there. And I think, that should be all we need. And that center we should label. It's going to be HK, center of a circle. And we know one of these coordinates, correct? We know the y value. The y value is 2. So it's really just H2, like that. Because if you draw a line from the center of the circle all the way to the edge there, that is a right angle. Why? Because it's tangent to that line. Okay? Tangent to the y-axis. All right, now the equation of a circle, if you remember, is of the form x minus h squared plus y minus k squared is equal to r squared, like that. And x and y obviously are the coordinates, but h and k represent the center point. So I'll put that in there. HK is the center. And R, of course, is the radius. So that equation we're going to utilize. And the good news is we know K already. K is 2, based on the information they've given us in the question. So let's start plugging in that formula. We have 2 points that we know. We have this point and we have this point, like that. So here we go. Let's first plug in 0, 2. So we have 0 minus h squared plus 2 minus k squared, but k is 2, right? And that equals r squared. So this gives you h squared is equal to r squared. So h is equal to r. All right, that's pretty simple enough. All right, let's start with the other one, 8, 0. Plug in 8, 0, and we get 8 minus h squared plus 0 minus 2 squared is equal to r squared. So this is 64 minus 16h plus h squared plus 4 is equal to r squared. And this becomes, let's see here, 68 minus 16h plus h squared is equal to r squared, like that. And h is equal to r, right? So we can substitute that in. Minus 16h plus h squared is equal to h squared. And the h's will cancel. So all you're left with is 16 minus 16h is equal to 0. 68 is equal to 16h, and therefore h is equal to 68 over 16. So that was what, 34 over 8, which is 17 over 2. Sorry, 34 over 8, 17 over 4. Right, like that. I basically divided top and bottom by 4. All right, that's good. What did we want in our question? We wanted the radius. Well, h is equal to r. So if h is equal to 17 over 4, r is equal to 17 over 4. All right, and that's it. So 17 over 4, that would mean 15 is C. In triangle ABC, AX is equal to AD and CY is equal to CD, as shown. The measure of angle XDY is. All right, let's start labeling this the best we can. Where do you want to start? These lines, what do those lines mean? They mean that those sides are equal. So therefore, this is an isosceles triangle. So therefore, this angle is going to be the same as that angle. Okay? And therefore, this angle, because all this, the sum of all the angles is 180, will be 180 minus 2a. Okay? And then very similarly in that triangle, if those two sides are the same, that's also an isosceles triangle. So if this is B, this angle will also be B, and this angle would be 180 minus 2b. All right? And the angle they want us to figure out is XDY. So XDY, this guy in here. So we'll call that M. You can label it anything you want. So that means that if you look at all of this, all the angles about a line are equal to 180. So that means 180 is equal to A plus M plus B. So that is our first relationship. Now our second relationship involves the entire triangle. That whole thing right there. And in that whole thing, the sum of the angles, in particular this one, and this one, will equal 180. So we have 180 minus 2a, plus this angle is a 90-degree angle, plus that one, 180 minus 2b. So you do the math here. Let's see, the 180s cancel. This becomes 270. And put the 2a and 2b on the other side. Factor out the 2, and this becomes 135. Correct? Now we can use the fact that a plus b is equal to 135 and substitute it back into this guy right here. And then bring it over here. So that means 180 is equal to a plus b plus m. But a plus b we figured out was 135. And therefore, m would be equal to 180 minus 135, which is 45. So x dy is 45, so 16 is C. 3 different numbers are chosen such that when each of the numbers is added to the average of the remaining 2, the numbers 65, 69, and 76 result. The average of the 3 original numbers is. So I'll let the numbers be A, B, and C. What do they want us to figure out? The average of these original numbers. So that would be A plus B plus C over 3. So this is what they want us to find. Okay, we'll keep that in mind. Now let's interpret the question. The question says that when you take a number and you add it to the average of the other 2, like that, it gives you a certain amount. And the first amount they gave is 65. And very similarly, you're going to keep doing that. B plus the average of the other 2 is 69. And C plus the average of the other 2 is 76. Like that. Okay? So how do we find that? Well, there's many ways you can isolate, blah, 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 right? All that stuff. But I looked at this and I said, well, just add them all up. add everything together. B plus C, B plus A plus C over 2, and C plus A plus B over 2 like that. And therefore, the right side would be 65 plus 69 plus 76. Multiply through by 2, get rid of these fractions. So we get 2A plus B plus C plus 2B plus A plus C plus 2C plus A plus B. 65 plus 69 plus 76 is 210. So if I'm multiplying through by 2, that'll be 210 times 2, which is 420. So as long as I didn't make any algebraic mistakes, I should be okay. So now I've got to add all this up. So I got 4A, B, 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 4B, C, C, it's 2C, 4C. There you go. Divide everything by 4, and that will leave A plus B plus C is 420 divided by 4 is 105. All right, great. Well, looks like we have everything that we need. A plus B plus C is equal to 105. So A plus B plus C over 3 would be 105 over 3, which is equal to 35. So number 17, the answer is B. In the diagram, the two smaller circles have equal radii. Each of these three circles is tangent to the other two circles, and each is also tangent to the sides of the rectangle. If the width of the rectangle is 4, then its length is. Okay, so let's start by drawing some lines, labeling some things. So first I'm going to draw a line from the center all the way to the tangent like that. And then what else will I do? Let's draw a line from the center to the top and all the way to the bottom like that. Very similarly, I'll do the same here. And what else can I do? I'll draw a line from the center of the big one to the center of the small one, like that. And one final line across like that. Okay? And now I'll start labeling this. So the radius of the big circle is obviously going to be 2, right? Because top to bottom is 4. So the radius has to be 2. So that's 2. And similarly, the radius of the smaller circles, there's 2 of them, so each diameter is 2, and therefore each radius is 4. Diameters are 2, so each radius is 1. So that means this guy right here, which represents a radius, is 1. And this one right here is 2. All right? So that means from here to here is 1, and therefore from here to here is 1. Okay? And similarly, since that is 2 from there to there, this is also 2, and this is going to be a radius, which is 1, and therefore that is also 1. Okay? So the only part we don't know to figure out the length, which is this whole thing, which is what they want us to figure out, is the distance from here to here, which I will denote as x. Okay? So if I can find x, I'm in business. So the one part I didn't label is from here to here. And I hope you can figure out what that is. From the center of the large circle to the end is the radius of that large circle, which is 2, correct? And from the center of the small circle to the edge is 1. So that whole red line is 3. Put that in big there. Okay, so now we've got a triangle like that. That is a right triangle. And we can use Pythagoras to figure out x, which is right there. So we have 1 squared plus x squared is equal to 3 squared. So x squared is equal to 9 minus 1. So x squared is equal to 8, and therefore x is equal to square root of 8. So length is this guy, 2, plus x, plus 1. So 3 plus x. And what is x? We just figured out that x was root 8. So the length is 3 plus root 8, and therefore the answer to number 18 is B. Cindy leaves school at the same time every day. If she cycles at 20 kilometers an hour, she arrives home at 4:30 in the afternoon. If she cycles at 10 kilometers an hour, she arrives home at 5:15 in the afternoon. At what speed in kilometers per hour must she cycle to arrive home at 5 in the afternoon? So the heart of this question is this formula. Speed is equal to distance over time. All right? We're going to use that throughout the question. Now, in the first scenario, her speed is 20 kilometers an hour. So 20. And her distance, well, we don't know the distance yet, so I'll just leave it as D. And the time, we also don't know the time. So use X for time. You can use T for time, whatever variables you want. So from this guy, I just get this relationship that 20x is equal to D. Okay, so far not much progress, but we keep going. Next scenario, 10 is now her speed, and she's coming home at 5:15. So the distance is the same, the distance from her school to her house, the same distance, but now it's 45 minutes more than before. So x plus 45 minutes. But we're talking in terms of kilometers and hours, so I have to change 45 minutes to hours, so that's 3/4 of an hour. All right, so that is our second equation. But the good news is we can substitute D into our second equation. So we have 10 is equal to D, but D is 20x over x plus 3/4. And this will allow us to solve for x, hopefully. So cross multiply, you get 10x plus 30/4 is equal to 20x. 30/4 is equal to 10x. And therefore x is equal to 30/40, which is 3/4. 3/4 of an hour. So 3/4 of an hour is 45 minutes. All right, so what does that mean? She arrives home in the first scenario at 4:30. If x is 45 minutes, that means she left home at 3:45. Leaves home at 3:45. Okay, in the first scenario. And I'm assuming that's also true. I'm assuming that is when the school lets out. So school ends at 3:45. She hops on her cycle and goes home. All right. Now we are at the final part of the question. And before we get to the final part, we need to figure out D, because we have to figure out speed in the final part. So we have to figure out D, because we want to figure out the speed, and speed is equal to D over time. Well, how do we figure out D? Well, we just use this equation that we created. 20x is equal to D, where D is the distance. X we got was 3/4 of an hour. So 20 times 3/4 is D, and therefore D is 60/4 or 15. And our units is kilometers. So she is 15 kilometers. It's a pretty far school. 15 kilometers from her school to her house. All right. Now, in the final scenario, we have to figure out speed. They want to know at what speed must she cycle to get home at 5 p.m. So speed is equal to distance over time. Speed is what we're trying to figure out. Distance we calculated as 15 kilometers. Time now. Be careful. X represents time, but we already figured out that she leaves home at 3:45. They want her to arrive at 5 p.m. So how many minutes is that? It's 1 hour and 15 minutes, correct? And we have to convert that to hours. 1 hour and 15 minutes is 5 over 4 hours. All right? Just be careful there. Don't make any small mistakes. So invert and multiply, and you'll get 4 over 5. And this is 60 over 5, which is equal to 12. 12 kilometers per hour is the answer to number 19. So the answer would be choice D. Point M is on the line y is equal to 5x plus 3. The coordinates of point Q are 3, negative 2. If M is the midpoint of PQ, then M must lie on the line. All right, let's draw a diagram here. So we've got the XY plane like that. And label this X and Y. And then we've got this line here. P is on that line. Y is equal to 5x plus 3. So very rough sketch. It's something like this, right? We don't know. I mean, it doesn't really matter. We don't have to be that precise. We just want to get an idea for the question. Now, P is on this line. So P is somewhere, I don't know where it is. I'll just say it's here. Okay? Like that. And now Q is a point somewhere. 3, negative 2. So approximately, if this is 1, 2, 3, negative 2. So somewhere here. Q, 3, negative 2. And then we are drawing a line between P and Q. So we're going to draw a line like that. And the midpoint of this line is M. So the midpoint is approximately here, let's say. Right there. And that's M. Now they're asking M must lie on the line. So I guess what they're saying is this line has what type of equation? And they've given you 5 answer choices. All right, so since M is the midpoint, we can figure out the equation with the midpoint formula. So M, I'll just call it x1, y1. We don't know what it is. But if you remember how to figure out the midpoint, if you have 2 points, A1, B1, and A2, B2, like that, the midpoint is basically equal to A1 plus A2 over 2 and B1 plus B2 over 2, like that. All right, so we have 1 point. The other point P, we don't have the actual coordinates, but the good news is that they've given you the fact that it's on a line y equals 5x plus 3. So if it has the coordinates x, y, it can be written as x 5x plus 3, right? Because y is equal to 5x plus 3, and that is the line that P is on. So we can just proceed with this midpoint formula. And we probably, I think I can squeeze it in. All right, I can squeeze it in. All right, here we go. So M, which is x1, y1, is equal to, so I'm going to add these two. These are 2 points. So x plus 3 over 2. And we have 5x plus 3 minus 2 over 2, like that. So x plus 3 over 2 and 5x plus 1 over 2, like that. I probably will need some extra space. All right, so that means that this guy is this guy, and y1 is 5x plus 1 over 2. So I'll write it over here. x1 is x plus 3 over 2, and y1 is 5x plus 1 over 2. Solve for x for both of these, so we get 2x1 minus 3 is equal to x, and over here 2y1 minus 1 is equal to 5x, and therefore x is equal to 2y1 minus 1 over 5. So we have x equal to this, and x is also equal to that, so we can set them equal to each other. 2x1 minus 3 is equal to 2y1 minus 1 over 5. Cross multiply and you get 10x1 minus 15 is equal to 2y1 minus 1. 2y1 is equal to 10x1 minus, add 1 to both sides, so you get minus 14. And finally, if you divide through by 2, you'll get 5x1 minus 7. So this is the equation of the line that M is on. 5x1 minus 7. Let's see if any of these match. I'll write it up here. y1 is equal to 5x1 minus 7. And yeah, choice E matches that right there. So number 20, the answer is E.